Hello, third hour college algebra trig, and welcome to 10.5 binomial theorem, and we're going to be talking about Pascal's triangle. Some of you may have seen Pascal's triangle in Algebra 2 last year, but we're going to talk about where it comes from and how we're going to use it in today's lesson. All right, so Pascal's triangle comes from the fact that we are taking quantities and we are raising it to certain exponents, right? So if we started with x plus y raised to the 0 power, we all know that anything raised to the 0 power would ultimately be 1. Now, don't feel like you have to write all of this down. This is super overwhelming, so I just want to show you where this comes from, and then I'm going to go back up to the top. This is the top of my front page. I'll go back up to the top and show you what I want you to write, but for now we're just going to talk about it. So anything to the 0 power is 1. If I have the quantity x plus y to the first power, nothing's going to change in it, right? So that's going to stay x plus y, and my coefficients are still 1 and 1. All right, well, what if I take x plus y quantity squared? Well, in algebra, anytime we square something, that ultimately means we have to FOIL. So when I take x plus y times x plus y, and I FOIL all that together, I get x squared plus 2xy plus y squared. So now what are my coefficients? My coefficients are now a 1. I've got a 2 in the middle, and my coefficient on the y squared is still a 1. So I'm hoping that you're seeing a connection here. This 1 comes from that coefficient. These 2 comes from those coefficients. And then just like when we FOIL, you can see where the 1, the 2, and the other 1 are coming from. So can you take a guess what would happen if we took x plus 3 times x plus 3 times x plus 3? If there was 3 of them, then we would ultimately end up with this polynomial right here. So we'd end up with 1, 3, 3, 1. And these green numbers are what we call Pascal's triangle, which is focused on the coefficients of those polynomials. So let's run up here and fill in our Pascal's triangle really quickly. So we just learned that this is actually called row 0, but we just learned down here that our row 0 is going to start off with a 1. And then this is what we refer to as row 1 because they need to match the exponents. So row 0 has a 0 exponent, row 1 has an exponent of 1, and we learned that those coefficients are going to be 1 and 1. Row 2 has an exponent of 2, so we learned that when you FOIL those together, you should get 1, 2, 1, and so on and so forth. So row 3, what I'm doing is I'm actually adding these two together to make the 3, and then I'm building 1s on the outside. So I'm going to have these big diagonals of 1s, hence the term Pascal's triangle, because it's going to be triangular in nature. So I have the 1 on the outside, these two make a 4, 6, 4, and then I've got the 1 on the outside. All right, row 5, 1 on the outside, these two make a 5, 10, 10, 5, and a 1. And another interesting thing that you can be aware of is that you can always know what row you're in by that second diagonal. So row 0 has a 0, row 1 has a 1, 2, 3, 4, 5. So that second diagonal right there is your row number, just another pattern for you. It's not necessarily super important, but it is an interesting pattern. All right, and I'm going to stop there, and hopefully I made my point, and you can see the pattern. We could keep going on and on forever if you just keep adding those two adjoining terms together. So we're going to be using this today to expand binomials, which means we're going to have a lot of variables involved. So if you look very carefully, if I foiled this together 5 times, the x is in the front of the binomial, right? So if I multiplied this 5 times, my x would have a 5 on it. And then it's going to decrease in order. So it goes down to 4, 3, 2, 1, and then ultimately 0. All right, but my y's are going to do the opposite. So my x is going to decrease, but my y's are going to increase. My y would start at 0 because there's no y's out here, right? And then my y's are going to increase in power each time. So as long as you can kind of keep that in your mind, just think about foiling. My x is going to have the highest exponent first, and then my y's are going to decrease. All right, so let's give it a shot. Let's turn to example 1, which is going to be the second page of our notes here. All right, so we want to use Pascal's triangle to expand a plus b to the 6th power, because we really don't want to FOIL 6 times. That would be quite tedious. So what we're going to do is we're going to think about, all right, I'm on the 6th row of Pascal's triangle, right? So then I need to revert back to, what are my coefficients? 1, 6, 15, 20, so on and so forth. Okay, and I'm going to start writing in pencil in case this gets a little crammed. So I'm going to start with 1, 6, 15, 20, 15, 6, and 1. So now the next step that I'm going to do is I'm going to start with my A, remembering, okay, if I FOILed 6 times, my first term would have a to the 6th power on it. And then this would be a to the 5th, a to the 4, and on down the line. Please make sure you go ahead and you write a to the 0 so that you remind yourself, oh yeah, a went all the way down, it's just the fact that it's raised to the 0 power. If at any time you're feeling overwhelmed, please press pause and rewind. It's the glory of having a video is that you can press pause at any time. You can rewind if you need to review something or if I've gone too fast, so please take advantage of that. All right, so we're going to go opposite with the b's, though. The b's are actually going to increase. So my b needs to start at 0 in order for this to work. And we're going to increase all the way up. And this should make perfect sense, right? Because when I FOIL this in the back I should have b to the 6, and in the front I should have a to the 6, so that I know I'm all good. All right, and then my last step is just to simplify where needed. So I've got a to the 6 in the front, 6a to the 5th b, 15a 4b squared. This one was pretty friendly. There's not a whole lot that needs to be simplified because I was trying to ease you in a little bit. So there's that whole thing expanded, and we didn't have to FOIL a whole bunch of times. All right, so this one is going to get a little bit more complicated because of the coefficients. All right, so remember, we are in row 4. So I always begin by using my Pascal's row coefficients. So I know in row 4 I have a 1, I have a 3, I have a 3, and then I have another 1. So I'm setting myself up. And we actually need 4, 6, 4. So let's go ahead and erase these. So we need 4, 6, 4, 1. And I knew that wasn't right because I knew if I'm in the 4th row, then my second entry should have been a 4. All right, so if I start by FOILing this, 2x is going to get raised to the 4th power because that's what's in the front. And I'm putting this in parentheses because that 2 is going to cause extra work for us. And you'll see what I mean here in just a minute. All right, so there's my 2 x's. Now I need a negative 3y. Please make sure you got that negative in there. I'm starting at 0. and then I'm going to increase all the way up. And then I stop at 4 because I know that my 4 is in the back. All right, so please be careful. These are in parentheses because the exponents have to distribute. So I need to take 2 to the 4th power, which is 16. And then anything to the 0 power is 1. So I know that that one's done. 2 to the 3rd power is 8. And then anything to the 1st is going to stay the same. So I still have some more work to do there. 2 squared is 4. Negative times a negative makes a positive 9. Negative cubed would still be negative. And then a negative to the 4th power would ultimately be positive. And want to make sure we get all of our exponents on here. So I've got x to the 4th. I should have x cubed, y. Then I should have x squared, y squared. Then I should have x, y cubed, and finally y to the 4th. So I'm all good. All right, last step, we need to multiply all of our coefficients together. So I've got 4 times 8 times negative 3 should give us negative 96. And you can go ahead and put minus there if you'd like, since that ended up being negative. And then 6 times 4 times 9, 216. 4 times 2 times negative 27 should be negative 216. I hope that you are double checking my math, and yeah, all I did on that last step was just multiply all these coefficients together. So I've got to multiply the 4 times the 2 times the negative 27, and I'm getting negative 216. So hopefully you're double checking me on that. All right, so there is something called a factorial. A factorial is that little exclamation mark that some of you have seen in your calculators or in your textbooks. And what that means is, for example, if I had 4 factorial, what that means is you're taking the number 4 and you're going to multiply it by every whole number that comes below it until you get to 1. So once you get to 1, you stop. So for example, 4 factorial, 4 times 3 is 12, times 2 is 24. And we're going to be using this in our next section here, so I'm trying to warm you up a little bit. All right, so another important ones to know, 0 factorial is defined as 1, so you're going to need to know that. 5 factorial is 120. 6 factorial, 720. 7 factorial equals 5040. And then 8 factorial, 40,320. So just some common ones. The more that you're familiar, kind of the faster and the easier things will be for you. So just kind of wanted to give those to you. All right, so there's something called a combination. A lot of times this is used in statistics when we talk about combinations and permutations, but we're not so much using it for stats as we are using the binomial theorem, which is used to expand binomials, which is what this section's all about. All right, so what you're going to do is you're going to take that first number. So this is how many you have like total. So let's say I have 14 students in my class total, and I'm choosing 8 of them. So maybe I have to send 8 students to the library, you know, in no particular order. So I would take 14, choose 8, right? So 8, choose 14 doesn't make any sense because you can't have 8 items and then choose 14 of them. That doesn't make any sense. So just so you kind of know what that means there. All right, so you're going to take the total. As a factorial. So I'm going to take 14 factorial, and then I want however many I'm choosing 8, so I'm going to take 8 factorial, and then I'm going to take the difference, right? So 14 minus 8, if I chose 8 of them, how many would be left over? And you would say 6. All right, so I also want you to think about what this factorial means, right? I want to be clever. We can do a little bit of canceling here, but we have to be smart about it. If I have 14 factorial, that means I'm starting with 14 down to 13, all the way down until I reach what number? 1, Miss Peterson, hopefully is what you're saying. Okay, so this goes all the way down to 1, correct? Well, if I'm being smart, then instead of going all the way down to 1, couldn't I rewrite that section as 8 factorial? Because I'm starting with 14 to go all the way down to 1. So instead of writing all those numbers, I could just write it as 8 factorial, because that would still go down to 1. So 8 factorial would cancel out with 8 factorial, and it just makes the algebra a little bit easier. So you can go ahead and plug this in your calculator. So go ahead and multiply all of this in the numerator in your calculator first, and then divide by 720. All right, and when you do that in your calculator, hopefully you are getting 3003. And if not, hit pause, try it again. If at first you don't succeed, hit pause and try again. Okay. All right, so I said all that just to say this. We are going to be using the binomial theorem, which allows you to use n choose k to find coefficients instead of Pascal's. So instead of using Pascal's triangle all the time, we can go ahead and use n choose k. Because what if we wanted like the 25th? Well, we don't know the 25th row of Pascal's. So this allows us to do some higher numbers, all right? It's very important that you start with n choose 0. That is something that a lot of students forget. When we are setting these up, you need to start with n choose 0. And again, we are using this to find coefficients. All right, so please make sure you've got these little bits of pieces highlighted in your notes for you. All right, let's go ahead and give it a shot. Example number 3. We want to use the binomial theorem to expand this. Okay, so we've got to the 4th power. So remember what we had to start with? 4 choose 0. You've got to start with choosing 0. And then I've got 4 choose 1, 4 choose 2. So it's kind of like Pascal's. I set myself up because these are coefficients. So I set myself up in the same way. And then I'm going to use, I got to start with a, right? So if I FOILed all this out, this would be a to the 4. So this is a4, a3. These are going to decrease just like what we did earlier. And then I've got a negative 2b squared. Haha. They're very tricky. Make sure you squeeze that b squared in there because that's going to be important. Negative 2b squared. Negative 2b squared to the 3rd power, and negative 2b squared to the 4th power. Lots of little details here. All right, so then you can go ahead and you should be able to do this on your calculator as well, the 4 choose 0. All right, so when we use the formula for 4 choose 0, remember we are taking 4 factorial, and we're choosing 0 of them, which would mean I'd have 4 left over, right? So ultimately, that's just going to equal a 1. So my first coefficient is a 1, a to the 4, and then anything to the 0 power is a 1. Whew, got that one. All right, sweet. So then 4C1, this would be like saying 4 factorial. I'm choosing 1, which means I've got 3 left over. So that number right there becomes should be a 4. And then I still have to multiply by that -2 later on. 4C2 should become a 6. And then 2 squared is 4, and then b squared, so that becomes b to the 4th power as well. And then 4C3, I'm choosing 3, I have 1 left over, so that becomes a 4. -3 cubed is -8, and then 2 times 3 gives me 6. And then 4 choose 4, there's only one way that can happen, right? If I had 4 apples and I chose all 4 of them, then there's only one way that can happen. And then -2 to the 4th power would give you 16. 2 times 4 is 8. All right, clean it all up. I got a to the 4. This gives me -8. That gives me a 24. Gives me -32. And that gives me 16. Lots of little algebra steps in there. Rules of exponents. Whoop, whoop. Yay, rules of exponents. All right, find the coefficient of the 4th term. Now, all we want is the coefficient, so we don't have to do the whole shebang. Number 3 was pretty intense, but we just want the 4th term. So remember, if I started with choosing 0, then my 4th term would actually be choosing 3. Do you see that? So a lot of students forget that this is where you start. Okay, so the coefficient is going to be 10 choose 3. So I've got 10 factorial over, I'm choosing 3, which means I have 7 left. So altogether, if I'm clever, I can cancel out the 7 factorials. Do you see that? And then I can use my calculator to calculate the rest, and hopefully you are using your calculator right now and you're pressing pause when needed, and hopefully you have 120 as your final answer. So that's just the coefficient for the 4th term. All right, find the coefficient of the x to the 7 y term. Oh boy. So let's think about, what does that mean? Well, we kind of have to think backwards, right? If I were to FOIL this out, my first term would have x to the 8 on it. Would you agree? So I've got to think to myself, okay, my first term has x to the 8th. So if this has an x to the 7th, then in other words, this is the second term. Hopefully you all are thinking that with me. So if I'm looking for the second term, I have 8 choose 0 as my start, and then 8 choose 1 would ultimately be the coefficient for my second term. All right, so let's use the formula. I got 8 factorial, I'm choosing 1, which means I have 7 left over, and if I'm clever, I can cancel my factorials. So I get 8 over 1, which is 8. And that makes perfect sense, right? If I had 8 apples and I only chose 1 at a time, how many different ways can that occur? Well, that's going to occur 8 different ways because I have 8 different apples. All right. We're almost there. Home stretch. Okay, number 6. Find the coefficient of the x squared term. All right, so now we really got to think here, peeps. If I'm factoring 6 or foiling 6 times, then my first term would have a 6 on it, right? So then I got to think backwards. Okay, I got x to the 6's in the front. So I got to think, okay, I'm trying to get x squared. So I got to go x6 all the way down. So what term is that? That is actually the 5th term, right? Okay, so let's think about it in terms of a combination. Combination, I'm choosing 0, then I'm choosing 1. So ultimately, these don't line up until I choose 4 in order to find the coefficient. So I'm going to go ahead and do that. So I've got 6, I'm choosing 4, I got 2 left over. 6 times 5 times 4 factorial. These cancel. So that leaves me with 30 divided by 2, which is, 15. All right, there you go. And a last one, just to give you a little practice. I know that we struggle with these, so I just wanted to give you a little extra nudge. All right, write the sequence in sigma notation. All right, so I'm going to give you a minute to digest that. If you want to hit pause and then come back to it once you've got your final answer, that'd be a really good idea. So why don't you go ahead and hit pause right now. All right, and we're back. Hopefully you've had a chance to try it. And if not, that's all right, but we are going to go for it. So in the spirit of factorials, this one starts with n equals 1. And it probably would have been a little bit easier to start off with that, so I should have had that typed on there. But if we start with n equals 1, I want you to think about it this way. I'm inputting a 1, and then I'm inputting a 2, and then inputting a 3, because after all, these are functions. So we are inputting x values, and we are getting outputs spit back out to us. So I also want you to think about our factorials today. If we had 1 factorial, what would that equal? 1. If I had 2 factorial, what would that equal? 2. 3 factorial, 3 times, it would be 3 times 2 times 1, which would be 6. 4 factorial, 24. 5 factorial, we said was 120, I do believe. So, do we see any commonalities between our factorials? How do I get from a 1 to a negative 2? 2 to negative 1. 6 down to 3. 24 to 21. So hopefully you're seeing the fact that, oh yeah, look, they subtract by 3 each time. So we are taking n factorial, and we're subtracting 3 each time, and we're going to keep inputting values until we get to 5. So that was definitely a hard question. These are hard in general. Just trying to figure out how do you take a sequence and put it in sigma notation. We all struggle with that, so no worries on that one. This is your assignment. They are all odd so that you have the opportunity to check your answers in the back of the book. So go ahead and make sure you're taking advantage of that opportunity. And I will see you guys when I come back on Wednesday. Protractor Club, we out.